Traditionally, when you're doing transformations of functions, you're looking at an equation and you have to graph it, or you're looking at a graph and you have to find the equation. But sometimes you're told to do things in a certain order. You're told to build an equation based on a parent function that I have right here, and you have to follow a certain order of transformations. Now, normally in class we talk about doing stretches first and shifts last, or reflections first. It really doesn't matter, as long as the shifts come last. But in this case, we don't really have that option. We have to follow the specific order. And you'll see that actually makes a pretty big effect on the equation. And I'll just give you a quick explanation of why. Imagine if you had a graph like this, the x squared function, and you were told to shift it down. So I'll show that right here. So we were told to shift it down. And then I was told to flip it over. Okay, if I then flipped it over, and we'll do that in orange, see, I would get something like this. Okay, that's the fully transformed function. And that's much different than if you had flipped first and then shifted down. Okay, so let's go through these steps. And I want to show it carefully using function notation to help us through it. And you'll get a sense what I mean in this first one. Each one of these 6 steps that I have right here, I've explained again down here. See, I explained what the step is. Shift down by 1. That's our first step. So let's start with that one. I have this square root function and I'm shifting it down by 1. Well, that's a vertical transformation. So it's going to be f of x, and the shift down is going to be outside the parentheses because it's vertical shift. Now, once I see f of x minus 1, I can just plug in my equation and say, oh, f of x is square root of x. And then I have that minus 1. Okay, so now I'm ready to move on to the next one. Now I want to do step 2, which is a vertical reflection on G. Well, think about this in terms of function notation. What is a vertical reflection? It is a negative sign outside the parentheses. Okay, so I'm applying a negative sign to the G of x now. But what that means according to the equation is negative times square root of x minus 1, which we could rewrite as negative square root of x plus 1. And I think it would be easiest if we simplified that at this stage. So I'm just going to go ahead and I'm going to grab this guy, move it over, and let's write the simplified form in here. So that's going to be negative square root of x plus 1. Okay, next, I'm going to shift right by 2 units. So we're going to take h of x and we're going to shift it right by 2 units. Well, that's a horizontal shift. So that's going to be x minus 2 inside the parentheses. Now, what does that mean for the equation? Well, we take a look at our last equation, and we replace the x with an x minus 2. So that's not too bad. We just take out the x from the square root and say x minus 2 instead. We still have a plus 1 outside. Okay, next step, I've got a vertical scaling by a factor of 3. Now, if you think about what vertical scalings are, that means multiply by something. So j of x will equal 3 times I of x in function notation. And what that means here, and I'll write it over here first, is 3 times the I of x equation. Well, the I of x is this thing right here, that thing I just circled. So we're going to have to put that whole thing in this parentheses. 3 times negative x minus 2 inside the square root, and then plus 1. And I'm just going to simplify it so that parentheses don't get too big. This will turn into negative 3 times the square root of x minus 2. And remember, we distribute that multiplication. So it'll be plus 3. Moving along. Next step I want to do is a horizontal scaling by a factor of 1/4. Okay, so what does that mean? Horizontal scaling by a factor of 1/4. Well, that, if you remember, we have these funny inverse rules with how horizontal scalings work. K of x is going to be equal to something that happens to j of x. And you might think, well, it's horizontal, so it goes inside the parentheses. Totally right, it does. But it's not 1/4, it's 4x, because we do the inverse of horizontal scalings. Okay, so now I need to figure out how to multiply x by 4 inside the parentheses. Well, really, you're just replacing that x inside this equation right here, inside j of x, with a 4x. So that's not too bad. This is just negative 3 on the outside, then a square root, and then instead of x, I'm going to have 4x. See, I'm replacing the x by 4x. Then I have minus 2, and then plus 3 on the outside. Okay, and finally, we're at the last step. The last step calls for a horizontal reflection on k of x. Well, think about what that means in function notation. L of x in terms of k of x is going to look like this. It's going to be k of not x, but it will be negative x because it's a horizontal reflection. The negative sign goes inside the parentheses. So if we just take this whole equation from here, right, if we take that guy, I'm going to write the whole thing, except I'm going to find the x and replace it with negative x. So it's negative 3 times the square root of 4 times, see, I could write it like this. I could say 4 times negative x. I don't need to write it that way. I can just say negative 4x. Negative 4x minus 2 plus 3. Okay, so there's how you work your way through a series of transformations that are not done in the order that you would prefer. You have to follow a certain prescribed order. And notice that I relied very heavily on function notation. I would have gotten messed up in this thing in step 2 otherwise. Function notation is really your friend. If you just think in terms of g of x equals something happening to f of x, just determine what these things are using function notation. It's a much easier way to guide yourself through the problem.